Hey y'all, we are going to look at inverses, additive and multiplicative inverses. Top left purple, it says additive. When we're talking about an additive inverse, we are looking for a number that when added to another number results in 0. My example there is a plus negative a equals 0. Easiest way to think of that, like I always say, is money. If I have $5 and I add to that a negative $5, I would get 0. So that would be an additive inverse. The other one that we have is multiplicative. This is a number that when multiplied to another number results in 1. So that example there is if I have the number a and I multiply to it 1 over a, what I get is a product of 1. Okay, so I've got a note right there that whenever you have the additive inverse, you use the same number with a different sign. So the same value numerically, but with the opposite sign, with a different sign that the original number has. And when you do the multiplicative inverse, you use the reciprocal of the number with the same sign. Okay, so let me make sure that y'all see that. So with the additive inverse, we use the same number, different sign. Multiplicative inverse, we use the reciprocal that has the same sign. Okay, so let's do some examples here. On the right-hand side, say they give us the number 8, and they want to know the additive inverse. So what number can I add to 8 to get to 0? My note says use the same number with a different sign. And then for the multiplicative inverse, it tells me to use the reciprocal with the same sign. Reciprocal, if it's a whole number, becomes a fraction under the number 1. And if it's a fraction, what you do is you flip the top and you flip the bottom. You switch places. So let's look at this number. Say we have negative 12. Additive inverse uses same number, different sign. Multiplicative inverse uses the reciprocal with the same sign. Okay, what if we have a fraction, 4 over 7? Well, the additive inverse tells me same number, different sign. Even if it's a fraction, it's just the same fraction, okay? And then the multiplicative inverse tells me to use the reciprocal with the same sign. And y'all, this is pretty much the exact format over here on the bottom right that you'll see on your homework for, I believe it's 9.7. Let's say we have the number x, and it wants to know its additive inverse. Well, you use the same number, different sign. Multiplicative inverse, reciprocal, same sign. So that negative x will result in a 0 if I combine together x and negative x. And then that multiplicative inverse, 1 over x, if I combine x and 1 over x, I get 1. And I'll do one of these over here to the side just so it can really make some sense for you, okay? Lastly, let's look at the number negative y. What can I add to that to get 0? Well, my note says same number, different sign. And then for the multiplicative inverse, I use reciprocal, same sign. Okay, so let's look at the 4 over 7. If I have 4 over 7 and I add to that a negative 4 over 7, because technically what we're doing is we're subtracting the fractions, right? Because of that plus sign, you could say that we're adding the difference of these two fractions. But if you look at your numerators and you look at your denominators and you pay attention to your signs right there, I can simply do this operation straight across the top and keep the bottom because they have the same denominator. So what you get is 4 minus 4 over 7. 4 minus 4 is 0 over 7. 0 over anything. We've done this in a previous video. 0 divided by anything is just 0. So do you see how what I did was I added the same number, different sign, and it resulted in a 0. So those are additive inverses. Now I'm going to scoot up just a little bit, y'all. For the multiplicative inverse, I said if I have 4 over 7, what I need to do is multiply it by its reciprocal, same sign, right? Well, this is going to be multiplying fractions. There's 2 different ways you can go about this. You can multiply the top and get 28, and then multiply the bottom and get 28. 28 over 28 is just 1, right? Or what you can do is go ahead and right here notice that you have something similar on the top and on the bottom that can cancel each other, and do that first. I know that 7 divides 7 one time. What I do to the top, I have to do to the bottom, right? And I know that 4 divides 4 one time. So what I end up getting on that left fraction, that 1 over 1 times, look at that right fraction, 1 over 1. Y'all, 1 times 1 is 1 over 1 times 1 is 1. But 1 over 1 is 1. So that's an example of the actual math of how an additive inverse and the multiplicative inverse works. This is being introduced to you in 9.7 at the very end. There's a couple of problems that we'll use like this train of thought right here, but this is the most important thing, I believe, whenever it comes to 9.8 and solving the equations that we're going to have with x's and y's and a cubed and z to the 4th power and one individual problem that has x, y, and z in it. Like it can look really confusing, but as long as you remember the additive inverses and the multiplicative inverses, you'll notice a lot of times that some things will cancel, which is what they want you to notice. They're going to throw a bunch of stuff into one problem just to see, did they notice that in one problem they have an 8 and a -8? Well, what happens with sorry, that was my alarm. It's like 5 o'clock in the morning. What happens with an 8 and a -8? Well, they're inverses. They're additive inverses. They cancel each other. They make it go to 0. Therefore, they kind of go away in the problem. If you don't recognize that it's an additive inverse, it does look like there's just a whole bunch of different terms and you could get easily confused. So make sure you really understand this. And if you do have any questions, make sure you ask me, okay? I'm going to actually do an example right now that I know is at the end of your 9.7 homework, which is technically the properties of real numbers. And this is what it looks like. What we have is a -1 over 5. We're going to add to that. So that's a positive 2 over 7, and then a positive 12 over 7, and then a positive 1 over 5. This is where a few of the different properties that we've learned come into play. So I know that I have the ability to move things around, right? To use the commutative or commutative property. And what I notice is that these 2 terms right here, those have the same denominator. So I actually want to move those together. And then the remainder of my problem was 2 over 7, 12 over 7. Now look at this. If I have a fraction and I add to it the exact same fraction with a different sign, I get to 0. What is this? This is 1 over 5, and added to that's another 1 over 5. The signs are different, right? So that's where I have the ability, they cancel. Technically what's happening here Oh, that was the wrong color. Right there, y'all. That was my additive inverse. That goes to 0 plus 2 over 7 plus 12 over 7. So now all 4 of these terms right here just became 0 plus 2 over 7 plus 12 over 7. 0 plus anything. That 0 is not mathematically changing the value of anything. So yes, I did write it here to show you that I used inverses, but the only thing we need to be concerned with is the 2 over 7 plus the 12 over 7. And if you do this math right here, those have the same denominator. So I can add across the top and keep the bottom. If you do 2 plus 12, you get 14 over 7. Use your calculator here if you need to. If you ever have a denominator that can equally be divided by the, completely erase what I just said. Let's say this again. I get 14 over 7. Right here, use your calculator, because if you ever have a numerator that can equally be divided by the denominator, then what you end up getting as a quotient, as the answer, is just a whole number. Because if you think about it, 14 divided by 7, well, 7 goes into that equally 2 times. So that fairly simple answer of just a regular plain number 2 came from doing the math right here on all 4 of these fractions, because I noticed that I had additive inverses. Okay, so let me do this problem right here also. In the homework, you may have something that looks like 6. And then if you open up parentheses, we have C minus 3. This is an example of the distributive property. What we do is our 6 is going to multiply to everything on the inside. So we show that by doing 6 times C. And then now let's look at our 3. We do 6 times 3, which is 18. Y'all, the signs are different, so it's negative. That's your final answer. Those are not like terms, which is what we're going to do in 9.8. But for now, just trust me that you are going to take your 6 or whatever number is right here near the parentheses, and you multiply it to whatever you have inside of the parentheses, paying very close attention to the signs, okay? Okay, lastly, this is a very important example. This is something that you would see on an exam because of its importance, not only in this section, but in a lot of sections to follow. Say we have a negative sign, a parenthesis, a negative sign, the number 2, m plus 9n minus 4p. Okay, so does it really look like I can do anything? I've got a lot of different variables. Haven't really learned just yet what to do with these variables. If they could be added together, they probably already would have been added together. I'm not sure what to do, right? The only thing in 9.7 towards the end of the homework that you need to recognize is the fact that I have this negative sign right next to this parenthesis. That actually implies that we're going to do, there we go. That actually implies that what we're going to do is the same thing we did in this problem right here. I had a number and I multiplied it to everything on the inside of the parentheses. I actually have the exact same thing here, but instead of there being like a number 1, instead of there being like a number 2 or 3 or 4 or 5, technically what's here, ooh, really? Good morning to you too. Technically what's here is a number 1. It's that invisible number 1, right? What we're going to do is we're actually going to use that distributive law or property, not really law, but, and we're going to multiply everything by -1. Well, if you do -1 times the negative 2m. Break it down individual pieces. The numbers times the numbers. Look at the signs, and then don't forget your variables, okay? So 1 times 2 is 2. Those signs are the same, so it's positive. Don't forget your variable. Okay, now let's scoot over to this positive 9n. If you do 1 times 9, you get 9. Those signs are different, so it's negative. Don't forget your variable. Now let's look at the coefficients again on this last term. You get 1 times 4 is 4. Those signs are the same, so it's positive. Don't forget your variable. That is your final answer right here. I'd like y'all to see if you could recognize this right here. My 2 was negative, and then it became positive. My 9 was positive, and then it became negative. My 4 was negative, and then it became positive. So a special note that we could put whenever you see this, when you distribute a negative into parentheses, essentially what happens, all signs change. Okay, y'all. So I think that's a decent place to stop for here. This should allow you to do the properties of real numbers, all the homework. I hit snooze. I am going to do videos today for that last homework before we take exam 1. So if y'all have any questions, make sure you're asking me and make sure you're doing your homework, okay? Thanks, y'all. Bye.